Okay, let's get going. So we're discussing the crypto forecasting competition starting last week. So anyone want to share what they were able to look at over the last week?
All I've really looked at was trying to get a submission actually going. I sort of haven't done anything in detail yet. I was just like looking at, like some of those notebooks I showed last week. There's one guy who seems to have made about like 20 different notebooks with every single sort of method of tackling this problem that's possible. So I'd tried running a few of his notebooks, like the ones I'd looked at. I was looking at, he's got like a reinforcement learning one, and then he's got one that's sort of taken from that Jane Street competition, which is using some unsupervised bottleneck thing, which I have no idea what that is. And then I was just looking at one now. He's got like an LSTM one, but with all of his notebooks, I hadn't managed to get like a submission done from any of his. So some of the problems are in his reinforcement learning one, he uses like an external reinforcement learning library, which requires a notebook to have internet turned on. So you obviously can't submit that one because the notebook has to have internet turned off. And then his main one, I'm not sure what was wrong with it. It ran for hours and it never created me a submission file. So the only submission I've managed to do was there's like a notebook that is just about how to submit and about how their API works, about how when you're in the test phase, it'll return you like a block of data that you need to predict on, and then you create your submission for that and put it back through their API, and then you get the next block of test data. So I finally got a submission working with that, which gave me a score of -1. So I'm not winning the competition yet, but like at least I finally got a submission in. So that's as far as I've got, really.
Yeah, interesting, because I think, I haven't made submission either. I was like you, I didn't, in fact, look too much at his. The guy has like, and he has a table too, which is really nice, of what are all the different approaches he's kind of putting out there in terms of his notebook. But
yeah,
I went even more basic to refresh my memory on even any kind of forecasting or time series forecasting. So, and in fact, from what you're saying, I had a couple of questions. Don't know whether you're deep enough into the submission to be able to answer, but one of the things that I was wondering is somewhere in those two notebooks where they talk to you about, doing some basic stuff and then using their API, they talk about the fact that you have to be careful because there could be missing data in the test blocks that they provide as well. So is the goal, I understand that the goal is to predict over 14, different cryptocurrencies, but setting that aside for a minute, so we'll have 14 values, but for each row, but it seems like, as you said, they'll supply a test data batch, and the batch may not all be, the rows of the batch may not be sequential in time. Therefore, you need to take that into account, and it seems like the API will not allow you to proceed until each line of the prediction has been predicted. Is my understanding correct?
Yeah, so I think so. So already, like within the training set, as you say, there's like 14 different cryptocurrencies, and within that, some of the currencies, they hadn't even been invented by like the time that the data started. So for, I think it's like sort of like 10 out of the 14, they've got complete data going back to 2018, something like that. Whereas, a couple of the cryptocurrencies didn't start until after that. So in the training data, they're missing stuff from the start. And then for most of the currencies, I think it's every minute there's like a sample. But again, some of the cryptocurrencies, they don't have every minute. They've got like some gaps for whatever reason. And yeah, like in that case, they don't have a row saying like here's not a number or whatever for this missing minute. They just have the row missing. So like for some of the cryptocurrencies, you may have to like sort of deal with that, the fact that there's time gaps between them. And then in terms of the actual submission, when it comes to make the submission, yeah, like so as you say, through their API, you do like a loop or whatever. So you say like, give me a block of test data. So it'll give you a block
Right.
of however many rows of test data for all of the currencies that they have at that time, with I think yeah, like the time periods that they want predictions for, and so you have to create a prediction for each one. But like supposedly according to them, like yeah, as you said there, because of the fact that you can only get the next set of test data once you've submitted a prediction for each of the rows in the earlier block of test data, you do have to make a prediction for each one. But there's no guarantee, because of the fact that the competition goes into the future, there's no guarantee like all these 14 cryptocurrencies will still be available 3 months down the line, and so some of them may drop out. And so like you can't sort of just sort of predict all 14. You have to just take a look at what block of test data you're given and then predict on the ones you were given.
Right. And so one is they may drop, the other is any one of them may not have a value, or none of them may have a value for a consecutive timestamp. And it could be that there are any one of the 14 could be missing for the next timestamp, or the entire timestamp could go missing. So you may have one value in the test data which is of a particular timestamp, and then the next timestamp may be 5 minutes from then. I'm just making up the 5 minutes, but for example, right?
Yeah,
that's
exactly
my
that.
understanding. Would that be right?
Yeah, I think so. Yeah, so like at the minute, if you look at the training data, you'll have like a timestamp for 1 minute, and it might have like all 14 cryptocurrencies. Then the timestamp for the next minute might only have entries for say 10, so 4 may be missing. So you can't be guaranteed, even in the test set, that you'll have all of the 14. Some of them may be missing. Again, they may have like time gaps.
Right. So for every available time step in the test, you're expected to predict whichever of the 14 are still around. Correct?
Yeah, that's right. Yes. So okay. They'll give you like a block of test data, and for every row in that test data, you have to make a prediction, but you don't know like what the timestamps are going to be or what the cryptocurrencies are going to be.
Right. And it doesn't say this, and obviously it depends on the method that you use from what I understand, but you could potentially use the forecasted data that you forecast to forecast further down the road as well, and combine that with your trained model, right?
You could, yes.
That is, if you predict a batch and you have that batch of data now available to you to base your further predictions on.
Yeah.
That's what I thought, but I just wanted to get it clear. And it seems like, going back to my very early days of exposure to time series, it seems like what we'll need to do in this competition to even get our models checked out properly is kind of do, they give us, I don't know, starting in 18 till, I think, September of this year or some such thing. Anyway, it doesn't matter when they cut off, but let's assume for 2-3 years, or let's say 2 years, just to be for argument. Then after 2 years, and did they tell us anywhere, and I missed how long the forecasting test they will run for after the competition ends? Have they said it will be for 3 months or something like that?
in the timeline of the competition, it says.
I forget now whether I.
Oh yeah, so it says here. Yeah, so the final submission deadline is the 1st of February next year, and then the competition ends on the 3rd of May. So that's what.
Oh, okay.
February, March, April. Yeah, so 3 months it runs for after the submission deadline. So it'll be running for 3 months. Okay. And yeah, like that's the one bit I'm not sure about is the fact that, yeah, so like at the minute there's the training.csv file, which as you say has data for like the last 3 years up until September or whatever. Then there's also another file called supplemental, I think it's called.
Right.
Supplemental training. And it says that it'll take the training data from where the training data stops at the minute and take us up to the start of the competition, I think. So once the competition starts, it'll have all the data between September and the 1st of February. Yeah, so like it sticks onto the end of the training.csv, and then after that, then you're into getting the test data in blocks from their API.
Right.
But the thing is, like,
it seems. Go ahead.
I was going to say, yeah. So like, say like, so if you train your model on the training data and the supplemental training data, so at the start of February, that's fine. Then when the first piece of new data arrives in the test set, obviously you've like sort of trained your model and it's like bang up to date. But I wasn't sure what happens then, like say like a month down the line. Is it still trying to get you predict what happened in February, like even in March? Or I wasn't sure, like, does the supplemental training file, does it sort of get bigger as time goes on? So is it's always all of the data up until the day when you're trying to predict what's going to happen? So I wasn't sure what happens there.
Yeah, that's a good question. Meaning you're saying, do they kind of incrementally update or how does the supplemental file get updated, right? Like they could be doing it in chunk, like on a monthly basis, or they could be doing it on a daily or whatever, and even what data it contains, right? Meaning, I have to read up.
I haven't seen that, and like, just in their sort of description of what the supplemental training thing, it just like says after the submission period's over, that file will be replaced with the crypto asset prices up until the submission period. So it doesn't say like that it will update during the testing period, which is a bit strange.
Oh, so maybe, So maybe what they're saying is that you will need your model to read the training data, which is already available.
Yep.
And another file, which is the supplemental data, which will have the correct September to February date, and then predict on the test batches that you will be getting down the road.
Yeah, so like that's one way to look at it. So, but say come March, that means that you're sort of predicting for February, which has already happened. Although because of the fact that if their supplemental only took you to the start of February, your model doesn't know it's already happened. But all of those notebooks by that guy, as I say, like he's using auto updating data sets, which he's updating daily, or his auto updates them daily. So it's, in theory, during the test period of the competition, his data sets are going to be updating. And so you should have like sort of those daily prices. So if you were to use his auto updating data sets, then in theory, for all of the data that's gone before, even during the test phase, you'd be able to get the true prices.
Right, but auto updating, I have a question on the auto updating comment that you made. Does auto updating means that he's updating from an existing file? Because auto updating from internet would not be possible, right?
Well, I think it is actually because of the fact that, yeah, your notebook can't update from the internet because you got internet turned off. But your wire, I don't know actually. So the auto updating data sets, they're outside of the notebook, so like they can sort of do what they want because they're updating. I'm not. I presume that if a notebook's connected to an auto updating data set, then it also gets the new data.
Yeah, but an auto-updating data set, I mean, my point is if the notebook is reading from a data set that um, is available locally, then it's one thing, right? But the data set also, I mean, nothing, my understanding, and I guess we'll have to dive into it. So I'll make a note to go chase the concept down. But um, my understanding was that, if your internet, your notebook doesn't have access to the internet, then it can only operate off of whatever data it has gotten to that point, and everything beyond that, you can only go through the API that they provide. That's the reason they want you to go through the API and turn off the internet, because anything beyond February is something that they don't want you to look at anything external. That's
Yeah,
at least my takeaway.
I think though that, yeah, so your notebook itself, as far as I'm aware, yeah, so it can't connect to the internet, but the data sets themselves, like they are sort of within the Kaggle environment. Um, and yeah, like I think that's the whole point of it, like an auto-updating data set. It sort of does update itself. And so your notebook can have internet turned off, but you can still connect to one of these updating data sets. And I think it might still be updating, but I'm not 100% sure
Because
on it.
that one I need to chase up, because my initial understanding was somewhat like this, that you are allowed, obviously, we have all the data until September, let's say, and we train the model on that. And now, come February, there is a gap between September and February that data will be available until February, because the competition really starts based on our models that we submit only on whatever, February 1st. And at that point, meaning from February 1st onwards, we are only allowed to access data through their API, because as time moves forward, our model will be run by them, meaning they'll throw a batch of, or our model should be able to read in a batch when they provide a batch of data, and then predict, and then wait for, whatever calendar days to advance, then they'll run it again. And now you would, I don't know how often they run it, whether they'll run it every day or run it every 15 days or whatever, but you will now need to predict whatever timestamp data they have per minute between February and 3rd of May or whatever your date that you mentioned. But at that time, my understanding, and that's the thing I wanted to kind of, and based on what you said, I guess we'll have to dig a little bit more, is the reason they have this supplemental is right now they obviously can't provide that data, right? Because it is not available. But to a certain extent, meaning that guy who submitted, is getting around that problem by using auto update, because between September and, let's say, already it's November middle. So all that data is already available if you're using an auto updating data set. But what I'd like to dig into is, come February when we submit, my understanding right now would be you can't use the auto updating any longer. You would probably just need to go to your model should just use the training and the supplemental data to train itself, which is the supplemental data at that point is just a chunk from September to, it's another data file, as if your data has been split into two chunks, 2.5 years or whatever until September, and then September to February. That's at least the mental model I have, but I guess I'll have to validate whether my understanding is correct or not.
Yeah, and I don't know myself, but I'm not sure how they work. I've never used them before, so I would need to see.
Yeah, so that'll be interesting. That's something worth chasing. And you had mentioned briefly, and I haven't dug into the guy's notebooks, but you had mentioned briefly, yeah, that he kind of, was referring to Elon Musk tweets or this or that. But that kind of stuff cannot be used, right? Because your model cannot use internet
Well, again, yeah. So
availability.
he's created one of these data sets for each of the 14 cryptocurrencies. And then, yeah, like as a joke, he's also created a data set of Elon Musk's tweets. But as you say, come the start of February, you may not get any more tweets. And so if you're not getting that information coming in, you maybe can't use it.
Yeah, because, from what I recall, and I'm talking from memory, but, in this store sales prediction, which is the prediction competition, time series prediction competition that in, I think the Fast AI course, I think Rossmann or something was the name of the German store. So one of the things that they did, the third winning entry, and therefore the Jeremy from Fast AI was also doing was, looking at the weather and the holidays, and kind of utilizing, if the weather is bad, then that might have an effect on the store sales in that region. But I thought that would be an idea, but then I had to dismiss any thoughts of using the weather, although you could still use weekend or calendar information, but you can't use weather information because weather is something you will only get based on internet access. But you could potentially use calendar information, right? If people are selling or buying more crypto on Fridays than they are on Mondays, then that's something you can use. Correct?
Yeah.
Yeah. So I was thinking, we'd have to dismiss anything that's
So can you see that?
internet based. Yeah. Can see it.
Yeah, so he's got a whole thread about it. But yeah, so here, yeah, so he's like saying our auto data sets be able to use it, but as I say, I'm not sure if the auto data sets will keep.
Yeah, internet access disabled.
Yeah.
But without internet, any kind of and that's where I spent a lot of my time was spent on just coming up to speed on the various, what is XGBoost, then there is this LGBM, light gradient boosting machines, and then there's another one called CatBoost, and there's a whole suite of methods called histogram-based gradient-based machines, where, as I understand it, you kind of bucket the individual values instead of having thousands and thousands of individual numbers. You kind of bucket them into histograms. Like, if your values are between, I don't know, one coin is 500 and another is pence, or per coin. Let's stick with per coin. Per coin also, that is the number. Sometimes is 500 and sometimes is gone up to thousands, and you would be dealing with several orders of magnitude in terms of numbers, and you can kind of collapse that by bucketing them into histograms and then use your predictions of histograms to do that. So I kind of was going through all those methods, so at least I have a basic understanding of what the hell is going on with the application of those methods, or what it means to even apply those methods. And if people are interested, I can post the references. Maybe anyone else want to chime in if they've done some work or have become familiar with any of the techniques that could potentially be used or anything like that.
I kind of have a question. So if we have a successful submission before February 1st, is that guaranteed like to work afterwards, after February the 1st?
I don't think so, no, because
oh wow, okay,
yeah, like obviously it's a sort of good indication that things will work. But as I was like saying before there about their API, so you'll get given like a block of test data, and for every row in that you need to make a prediction and put that back to to get the next block of test data. So if for some reason, like at the minute you might successfully submit, but then in their new test data, say for example, like one of the crypto coins drops out and your code didn't cope with that, and then you didn't predict for every row, then you wouldn't get the next block of test data. But in theory, in theory, if you do make a successful one now, you're probably okay, as long as you don't have any sort of big generalizations in there where you're expecting to see everything, or you're expecting them to see all the time periods or whatever, as long as you guarantee that your code sort of will deal with missing things.
Right, and we can still select 2 submission notebooks, right, in the end?
Yeah.
Oh, okay.
Yep.
Yuri, are you saying something? Can't hear you. No, not yet, Yuri. You're still quiet. I can't hear you.
Yeah.
Still. Do you want to drop off and try rejoining, Yuri? Because we still can't hear you. So Dinesh, long time no see. So are you interested in participating in this competition? And
yeah, actually, I was away. the work pulled me away, and then I do not do the machine learning mostly. I do most of the data engineering side. But yeah, I'm interested to do this time series. One of the things which I would put in the channel, one of the podcasts I was listening, I don't have a name, just give me a second. He's doing a series of a time series. It's a good listening as if you have a time. So let me get you the podcast name if anybody is interested. He's doing, I think, this podcast for 2 months, couple of months, only on the time series techniques. It's called a data skeptic.
Yeah,
data skeptic.
Yuri just posted data skeptic.
Yeah, so he's quite good, and then he's bringing in different people, and then they're talking about time series, different techniques on there. But yeah, I haven't looked in. Sorry, go ahead, please.
No, that'd be great. Yeah, do post any pointers on the podcast.
Sure.
Okay, can you hear me now?
Yes, Yuri.
Okay, cool. Sorry, I'll change the microphone. So I looked at the data just now, but so we're predicting something. We don't really have any external data, so it's predicting time series almost from itself. Is that true?
I think eventually that is the restriction we were discussing, because you can't access data from the internet. So
it's basically
now,
like
that said, you. Sorry, go ahead.
Oh yeah, but that's what the so you can have like information like volume and like, you know, like it's multi asset prediction, but essentially you just have information on what's been sold and the volume and like different other things that I don't know what they are,
Yep.
but like some financial thing. But
Yeah.
okay, so it's purely predicting
Right.
like next value from all the previous values. Okay.
Correct. Yeah. And you know, one thing you can utilize, and some people have already done that. I think, in fact, one of the notebooks, if I recall, Steve can correct me if I'm wrong, but one of the notebooks Steve was pointing to, I believe that guy already has downloaded data or has a pointer to data for some of the coins that goes back beyond beyond the start point of the data set available for the competition. So the thing to keep in mind is, as Steve already said, not all 14 coins have data going back to even the starting point they have in the data competition. But some of them do even beyond what they have as the starting point, which is, I think, 1st of Jan 2018. So some coins existed before that, and for that, your model could potentially use that data, because, you know, as long as you've trained the model on it, and, you know, you're no longer using it when you're disconnected from the internet, but you can use it as more data to train your model on.
Yeah, so that's right. Yeah, the guy's taking them back, I think, to 2017 if the data was available. And the other thing is as well, yeah, like say you're like looking at Bitcoin or whatever, you could obviously sort of predict how it's going to go up or down depending on what's happened by it itself. But then this guy that's made all these notebooks as well, he's got like a whole discussion thing about other competitions where it's been similar, and there's a thing called hierarchical time series. And so, like, as well as just predicting how Bitcoin is doing by itself, then you can look for correlations with the other cryptocurrencies. So if Bitcoin goes up, there's a good chance the rest of them will go up and stuff. And yeah, like he's got a whole thing about how you can sort of look at it at like loads of different from different angles or whatever.
Right. Yeah. But you know, the other thing I was thinking, and would appreciate comments or thoughts from anybody, is it seems for us to do a good job of testing, then what we should do, forgetting the auto update for a minute, let's just assume things are static, then it seems for us to be able to do a good job on any model that we train and predict, we should kind of set aside a test set which is towards the end of the data that is available, which is as long as the time between February 1st and March the 3rd, if those are indeed the cutoff dates, or whatever the cutoff dates happen to be, that many dates, if you will, although we won't know exactly how many timestamps that would be, right? Because some timestamps may be missing or not, but it doesn't matter. Assume that some rough chunk corresponding to that many days we would have to set aside as the test data from our current training data, and then use the remainder as training, and even there use a validation set which would correspond to the end of that training set. Is that at least that is what I remember was done in the sales forecasting type of situation. Does that make sense, or would people have different thoughts than that?
Yeah, how much data is used right now in evaluation?
At the minute,
it's
a bit strange. It's at the minute the test set is actually part of the the public test set is part of the training set, and I think it's 3 months long, maybe. But yeah, like so there's data
corresponding to what
leakage at the
the
minute.
eventual test set. Yeah, that's because, and he has said it explicitly, right? Because what they're saying is all this data is publicly available anyway. So it's kind of meaningless for us to give you a test set, because you can just go and get a test set which is available publicly, and you can kind of match it exactly if you just predicted that. But that's kind of meaningless stuff, because you would get a 1, but that doesn't tell you anything about the model really, if you haven't checked it in the way that I just said, of separating out the test set and then having another validation, the test set being the very end of what is your current training test, but as long as the eventual test set will be. And then from your training set, you still have to lop off the same amount as the eventual test set to create a validation set on which you can validate the model, because you just don't want to validate the model including on the test set, because by then you will definitely overfit.
Yeah.
Do you think people who have won on the leaderboard, they just cheated and submitted just to see if they can get that? Because there are a bunch of people that won.
There is like an actual notebook there, because of the fact that, as I say, like the public test set at the minute is contained within the training data. Yeah, so if you just chop off the last 3 months of the training data, that is the public test data. And there's a notebook that does that and gives you a score of 1. So if you want to come top of the public leaderboard at the minute, you can. But as Srinivas says, like the competition organizers have like made that clear, and the public leaderboard at the minute is just for sort of testing yourself. There's no sort of kudos and being the top of it.
Yeah, so I was looking at the Gen Street's that the competitions discussion page, and I found a notebook on how to generate cross-validation folds for time series data. And I think this would be like an important thing to do, which is to set up your own local cross-validation.
Yeah, so this guy that's made these data sets, in his notebook, he's got a link to the thing, which, as you say, I think it goes back to the Jane Street one. The only difference with the Jane Street one is it was like predicting on like normal share prices, which obviously like they're on like a normal stock exchange, and so like they have like an opening in the day and a closing in the day, and so like keeping your individual days prices together is very important, so as you avoid the leakage. Whereas because of like in cryptocurrency, like it's traded 24 hours a day, 7 days a week, there is no start and stop time for it. And so in some ways it's not as important to have that sort of cutoff that they're talking about. Yeah, like I think I've seen the same thread you're on about. But yeah, like certainly their cross-validation mechanism was good, but it may be that you don't need to worry so much about sort of keeping an individual day's prices together.
Right.
But the thing I was noticing though, Steve, is interestingly, while the data is provided per minute, they have OHLC data per minute, which means to me that only makes sense if they have data that is available sub-minute, but they just provide you the data per minute. You know what I'm saying? Because it makes no sense to say that open, high, low, and close per minute are these numbers if you don't have sub-minute data. Because if you don't have sub-minute data, then all of those 4 numbers I would expect to be the same, because per minute you just have a single value. But if you look at the data per timestamp, which is per minute, they provide, when I say per minute, they may skip minutes, but it is on a per minute basis as they indicate. But they have OHLC data for each timestamp, which means they have actual data sub-minute. Is my understanding right?
I don't know. Yeah, like I saw
you see
that.
What I'm saying though?
Yes.
Yeah, but
so
it's not available to us, right? So
Yeah. But I'm just saying that's the only way it makes sense to have OHLC data per minute.
Yeah, I agree. I think
right?
so.
Because otherwise, what does it mean to open and then have a high and a low on a minute when you just have a single data point otherwise? So for us, it's equivalent to treating it as per minute, but you do have the OHLC, meaning open, high, low, close, of that minute for every minute where the data is actually available.
Yeah, as you say, that in cryptocurrency trading, yeah, so like at the start of the minute is obviously the start price for that minute, and the close price is the close price for the minute. And then, yeah, like the data shows you like the number of trades and the volume of trades that occurred within that minute. So like as each of those trades takes place, I presume that the price changes. So like you may not have access to that, but
Right,
yeah, like there will be like an
you're
opening and a closing
it may not
price,
be
and like
sub-second, it may depend on the trade.
Yeah,
you're right.
But yeah, I wasn't
That's a
sure
good way to
myself.
think about it. It may not be a time unit as much as the trade occurs, the prices change, which is what is captured in that minutes, because there is a volume of trade provided and the price, I think, because there is this volume weighted average price thing too, right? BWAP or something.
Yeah. Was this the notebook you were talking about, Jack? Find the Holy Grail time series. This here's come from Jane Street, I think.
So yeah, the notebook
Yeah,
I shared was based on this one. So yeah, kind of similar.
Yeah. So yeah, no, I read this, and yeah, like I think it's got really good ideas about how to split up the folds and stuff. And yeah, like it goes through like in steps about how to sort of, yeah. So like within what you call it, this thing, scikit-learn. Within that, yes, like if you were to use like this normal sort of fold strategy, then if you were like to take this example here where you've taken like fold number 2 because you've got data before in time and then data after in time, and you've taken sort of like something in the middle of time, then you can obviously predict fold 3 so much better because of the fact that you can predict fold 2 in the validation better because you have the data before and after it. And so they're saying in the notebook that this sort of standard strategy for cross-validation isn't a good way to do it. And yeah, like they say that scikit-learn has like another, I don't think it's got a picture of it here. But yeah, so basically what they say is rather than doing like this mechanism, that you would just start off with fold 1, and then you would take fold 1 and fold 2 together, and then fold 1, fold 2, fold 3, they would be your training data. So like at each step of the thing, you add another fold on, but you never just take your validation fold in the middle of the data. And yeah, scikit-learn has some, this thing here, this time series split is a function that does that. But then this notebook is on about the fact that this time series split, it doesn't sort of cope with splitting your validation sets, so as you avoid having data from the same day in the training set and the validation set. And like they go into details about how to stop that happening. But yeah, as I'm just like saying there, I don't think that's important because of the fact that it's 24 hours a day and there is no sort of concept of a day really.
Right.
But yeah, like this notebook does explain how to do.
You'd still need to adhere to the principle that they're trying to enunciate, which is you cannot, any fold of yours should not have access to data which is beyond the fold.
Yeah, so
yeah, I agree.
This here's a picture here of their time series split. Yeah, so here in our case, yeah, like test set is the validation set or whatever. So as I say, you can see here they on each fold they add a bit more to the training data, but they never take the validation set or the test set in the middle. They always like take it at the end. And so yeah, like the size of the training set gets another fold of data added on.
So
For
if
each
you
one.
train models on these splits, would you say that the model trained on the third one would be kind of probably be the most reliable since it has the largest training set?
You would say so, yeah. Yeah, so
Okay.
like obviously at each fold, you're sort of increasing the size of your training set, so you would hope the model would be a bit better. But I'm not entirely sure then as well, like when you're doing the cross validation thing, where you're sort of comparing the results that you get in your validation set at each time, like you would say that at each one of these steps that you would hopefully get a better validation score. But I don't know, not sure.
The things like the test sets here, they overlap a bit with, yeah, I'm not sure, but I guess, yeah, I don't know. But it makes sense that the test set is always after the training set.
Yeah. But yeah, I haven't actually tried it yet, but it made sense or whatever. So
Interesting. Yeah, so as I was saying, I was just poking around on, if you can see my screen, right, the XGBoost, like you could use random forest regressor and use XGBoost and how that works of fitting kind of the residuals. And it talks about, kind of how it does, what algorithm it uses and stuff. And then there's multiple of these. This is just XGBoost, but there are variants. And this, the fascinating thing about it is there's not just XGBoost, but there's this thing called light GBM, which again is a gradient boosting method. Yet another variant. These XGBoost and light GBM seem to be very much in use for these kind of competitions. And the big challenge is not so much using, everybody eventually ends up on using one of these models, but is the parameters and what do you do with them. And there's like this blog on all of the different parameters that can be set and what effect they have, which multiple blogs refer to. So that's, I thought, was fascinating. And then there's this whole cat boost, which I don't know that it will be of much use for us, but what cat boost does conceptually is it automatically, it's same concept of gradient boosting, but is able to handle categorical data. Now, in our case, our data is regression and our forecast is regression, and most of our data is numbers because they're all prices in dollars. So we don't have, I think, much of a benefit from using cat boost, but I could be wrong and I have to dive into it. But bottom line, at the surface, it seems like cat boost is used predominantly when you have categories in your input data of time series that you can then convert quickly to numbers without you having to go through it manually and do it yourself. So those are the three, as I said, on gradient boosting machines, XGB, LGBM, cat boost, and then there is this whole histogram-based gradient boosting ensembles. And as I said, the concept here is just bucketing or creating histograms out of data instead of individual values, because the individual values, if you think of even stock prices and stuff, are just humongous, meaning every number is an independent entity. Instead, you bucket them, and that makes prediction somewhat easy. So you could again do histogram gradient boosting with XGBoost, light GBM, or cat boost. So this is kind of orthogonal to any one of the methods that you use, if you will, like gradient boosting or LGBM. And then there is this whole thing, as Yuri mentioned, as Steve mentioned, we are predominantly dependent on the time series data itself in order to generate some of the features that we would like to use to predict. And if we do that, I found this whole, I think it's a textbook online or something on forecasting about all kinds of different, but it's not that complicated. You can kind of go through this very quickly. It's R-based, unfortunately, but I was just trying to get an understanding of some of two topics in particular. One is exponential smoothing, where you kind of base because it's a time series, you kind of want to aggregate it, and you can use forecasting, which is the average, base prediction, or the naive prediction, which is every prediction is just the last prediction, whatever your last value is, and variations of that. And you can kind of use a exponentially moving running average, much like you use for some of the optimizations. And then there is this whole thing of what is called ARIMA models, which it turns out the term just means autoregressive integrated moving average models. And there's a whole bunch of terminology corresponding to these models that you could potentially use, and they use it, in fact, and they show examples of Google stock forecast, for example. So this is another thing that I just wanted to kind of gain an understanding of what this exponential smoothing is, what ARIMA models are. And then there is, I believe, orthogonal again to these are more methods to generate the features that you could then use. And of course, ARIMA is a modeling technique itself, but exponential smoothing is used in order to generate some of the data. There is this concept additionally that probably we'll need to get familiar with. It's, as with many things in machine learning, this is a new term, but it's fairly easy once you get the idea. So there is this concept of stationarity of time series and what it means. My understanding, anybody else feel free to jump in and correct me and or point to better references and stuff. But basically, stationarity means that over time, or it basically says that the properties don't depend on the time at which the series is observed. Now, in our case, explicitly, they tell you that the series obviously is not stationary. And one of the challenges we have is that is depending on which time period we sample from our data set, your prediction could be dramatically different. So that obviously makes the whole prediction business very tough. And so the goal initially, at least, is in trying to make your time series stationary, which is to say, and how you do that is there's a lot of discussion here about how you go about doing that, which is by taking lags and then using one of these other methods. And lags is basically difference between what you measure at time t and what you measure at time t minus 1, which is available to you, and t minus 2, t minus n. So this concept of stationarity in time series seems to be something that is often talked about, and something that at least I hadn't heard of or understood. So I kind of familiarized myself with that. And then it seems, at least in time series, and I saw the guy that Steve is referring to allude to this as well, that while LSTM, everything from reinforcement learning and so on have been used potentially, it still seems that in forecasting, a lot of techniques are simpler, and the simpler techniques or combinations thereof still tend to win competition. By simpler, I mean things like, the ARIMA models, time series, using lags to generate features, and using the XGBoost or LGBM or CAT booster variants thereof, and ensembling the models. And then there is the whole Google TabNet, which is for handling tabular data with deep learning. I haven't had time yet to dive into that. And for those of you who really want to drown yourself in all the various techniques that are available, let's see, just the one. Oh, I need to, I'll stop sharing and point you to something that I thought was just incredible, pretty incredible. Apparently, there is this whole series of competitions that are run. Give me a minute before I ramble on. Give me a minute to find the correct thing to share here. Let me know whether you see a Wikipedia page. And what I'm sharing. If not, I'm sharing the wrong window, so I need to switch. Can you folks see my screen yet?
Yes.
Yep.
Yeah.
Okay. And you can see the Pearson correlation coefficient, Wikipedia page?
Pearson code.
Yeah. Yeah.
Okay. So here's actually the thing that I wanted to share is apparently they run this periodically. I forget the name. It's called a M4, but there is actually the M stands for the name of a person. And it seems there is, and last year they ran the M5, but this competition and there's even a journal dedicated to forecasting that talks about, time series and the state-of-the-art method. And as you can see, they run 100,000 time series and 61 different forecasting methods, and kind of talk about, I guess, all the different ways in which they compare and contrast all these things. And everything is dedicated just to forecast. So obviously, at least it seems, I just thought it was fascinating. I wasn't aware that, but I shouldn't be surprised. Yeah, it's called, I believe, the Macrodacris competitions, and it's conducted, it seems, periodically. So I think there is an M5 that happened the M5 competition was, I believe, on Kaggle as well, which is the prediction of sales for Walmart. And you can imagine, the size of that data set and predictions, right? Like for all of the SKUs in all stores in Walmart. But I just thought it was fascinating that you could spend a lifetime. Obviously, we won't be able to do too much with this, but if you want to kind of, skim through it to see whether there are some interesting ideas that come out of it in terms of what can be applied and what seems to be the state of the art, you can go to that. So that's what I spent time figuring out, what the various terms mean and what kind of techniques, and hopefully next week I'll actually be able to get my hands dirty a little bit, like to even make some submissions or even do some ETA of figuring out what the lags, by lags is meant, the difference between day or minute n and minute n minus 1 and what they tell us about the data and things like that. And if you are interested or you already have the basics, then I won't waste your time posting it. But if not, let me know and I can post some of the links, because at least I had to go refresh my memory on the techniques and what they are actually doing and what kind of.
Please do post, Srinivas.
Yeah, so I'll post those links then. Anybody else want to share what they were able to look at? If not, good luck diving into some of the details and getting your hands dirty on this competition. It seems definitely to be a fascinating one, and once we overcome some of these questions we had about the basics of the competition, or even orthogonal to that, we should be able to at least play with the data and get ourselves familiar with it and see what begins to matter and so on and so forth. So I'll post some of the links that I pointed to once we are done. Anybody else want to say anything before we sign off? Okay, if not, see you all next week, same time, 10 p.m. Pacific. Oh, sorry, next week is Thanksgiving in the US, so we'll probably skip next weekend, which is Saturday 27th, and we'll start 2 weeks from now. So I think I'll post a bunch of references that ought to keep you busy over the next weekend, and we'll kind of have our next meeting the first week in December.
Okay, cool. I will see you in 2 weeks then.
Thank you.
Thank
Cheers,
you.
everybody.
Thanks.
See you all
Bye.
in 2
Thanks.
weeks.
Bye.
Bye.
Thank you.